Hi, good day and welcome to part 9 of the June 2021 CXC Maths Crash Course. So the first topic we're going to bounce up today is a circular theorems question. In fact, part A and part B are going to be based on circular theorems. Now, I did an entire video on circular theorems already, so you need to watch this video as everything in part A and part B. I'm just going to refer back to this video. All you have to do is type in this exact phrase in the search window here. Type it in exactly like this, and the first video that will pop up, the one with the kind of octopus in the background, a kind of moon in the background, will explain these 7 rules of circular theorem. Once again, if you go in another textbook and you look for circular theorems, you will see 7 rules again, but the rules will be in a different order. So for you to understand this video, you have to watch this video. Otherwise, it won't make too much sense. Okay, and you need to watch it in any case to prepare properly for the exam. So moving ahead, on the assumption that you watched the video, in part A, they want you to find the angle ACD. Right? No, you were given that the angle ACD is 134. So now they want you to find the angle AOB. AOB. That's this guy here. To find that angle, here's what I suggest we do. We find this angle first. Isn't this line here where the mouse is moving? You see the arrow? Isn't that a straight line? A straight line is 180 degrees. So I'm very sure we can find this angle very easily. We just have to take 180 and minus the 134, and we will get 46 degrees. Now don't lose track of the question. They want you to find this angle. To find that angle, according to the video, there were 7 rules. The rule we have to use for this one is rule 2. Whenever there's an angle touching the circumference and whenever there's one touching the center one is twice as large as the one touching the circumference. Now, to get full marks in the exam, you have to quote this formula. So memorize this for the exam. And what you're going to do, you see that small paragraph there? You need to write it over here. So you're going to write that same exact paragraph there. Then, afterwards, you're going to show them how they're going to calculate this angle. Because if here is 46, this one is touching the circumference. This one here is touching the center. The center one is be twice as big as the one touching the circumference. So that means angle AOB is equal to angle what? ACB, that's the 46, multiplied by 2. Right? So, excuse me there. Alright. And that has to be multiplied by 2. So all we need to do now is take the 46, multiply it by the 2. So how much is 46 multiplied by 2? And we get 92 degrees. But you will not get full marks unless you quote the formula that you are using. So in other words, all 7 rules that were mentioned in the video, you need to memorize them for the exam. So that's the final answer for part A. Look at that. We're finished so quickly. Let's move on to the next part here now. Part B. So for part B, they want us to find the angle XYZ. So to find the angle XYZ, XYZ, that's this angle here. This is going to be really easy. You all notice there's a cyclic quadrilateral here. X to Y, Y to Z, Z to W, W back to X. The opposite angles in a cyclic quadrilateral add up to 180. So you need to quote that formula over there. So that's this formula. I think that was number 4. Opposite angles in a cyclic quadrilateral add up to 180 degrees. So this small paragraph here, you have to write it in where this asterisk is. So you have to physically write it in. Then you're going to show them how you're going to calculate x, y, z. To calculate this angle, which is xyz, you have to take 180 and minus the 75. Because remember, these two angles here must add up to 180. So let's work it out. 180 minus 75. And we get 105 degrees. All right, so we just figured out here was 105 degrees. Now they want us to find the angle XWA. X, W, and over here is A. That's this angle here. You notice there are two parallel lines. In parallel lines, you have all these two angles here are alternating angles. Let me use a different color. This angle, this blue angle, and this blue angle are alternating angles. So you need to find this angle, and once we get this angle, we can transfer it over here because both of those angles are equal. How do we find this angle? All the angles in a triangle add up to how much? 180. So I'm going to show the examiner now that I'm going to find y, z, x. To find y, z, x, I'm going to add up the 38 and the 105 and minus it from 180. So it's 180 minus, open brackets, 38 plus 105. Let's work that out quickly. So 180 minus, open brackets, 38 plus 105. And that gives us 37 degrees. So here's 37. And over here is 37 because they're alternating angles. But you have to let the examiner know that you know that. So this angle here is WXZ. WXZ is equal to 37 degrees because YZX, because YZX and WXZ are alternating angles. Right, so you see what I'm doing, right? I'm making sure I'm explaining my steps to the examiner. Now, we could easily find this angle using Rule 7. You notice here's a chord. And this line, AB, that's a tangent. Let's take a look at rule number 7. In rule number 7, if you have a chord and a tangent, the angle between the chord and the tangent is equal to the angle standing on the chord. So if here is 60, below here is also 60. You need to quote this for the examiner. Right, so that same thing I just circled there. Right, but I'm running out of space here. Write it over here. Then you say ZWB is equal to 37 degrees. And of course, you already explained how you get here to be 37 because you quoted Rule 7. So the examiner has no problem now, like he understands how you are thinking. Don't forget the aim of the question. We're trying to find this angle. We're almost there. Isn't this a straight line? All the angles 1, 2, 3 must add up to 180. So to get the angle XWA, you have to take 180 and minus what? The 75 plus the 37. Let's work that out. And we're finished with the question there. We have 180 minus open brackets 75 plus 37. And I get 68 degrees. All right, so that's the answer. That's the final answer. So I'm sure there's another way to get this out. I just haven't seen it. I know this way was kind of long. So if you're watching this video and you saw another way of getting out B part 2, like an easier way, please let me know in the comments so everyone can benefit from it. Okay, guys? So let me just save that. Oh, I'm supposed to click save when I do anything. That's why things were disappearing sometimes. All right, so let's move down here. All right, part C. All right, now this is the part where this is like trigonometry now. Sine, tan, cosine, the sine rule, the cosine rule, stuff like that, right? So I think let me just see if I have anything here that can help out. Right? Give me 1 second here. Let me just pause. All right, so we're back. So first things first, right? This is where there's going to be a lot of trigonometry, like I just mentioned, and you're going to get a lot of bearings questions and whatnot. So here's what I suggest. A few things. We have to go through a few things, especially if you're not familiar with the theory. To understand the sine rule and cosine rule, I don't have any videos right now available to the public, but I did find a couple that were really good. All you have to do is type in this exact phrase here, right? This exact phrase on YouTube, right? Try to get it almost exact. And you'll see 2 videos come up first. The kind of black one on top and the kind of pink and yellow one here. You really need to watch those 2 videos. I chose these 2 videos because they would have explained it the same way, or almost the same way I would be explaining it in today's tutorial. So they will match up, right? They'll be in sync with what I'm doing. Also, when it comes to bearings, well, I have a pretty complete video on bearings. Just type in iLoveLessons bearings, and the kind of pinkish one here that has bearings written on it is a complete tutorial on bearings. So let's continue now under the assumption that you guys watched the video or are very familiar with the topic. Now I know I'm asking you to watch quite a lot, but that's just how maths is, right? I don't believe there's a shortcut in getting really good at maths. It takes a lot of hard work, it takes a lot of time, and it takes patience. Okay? Right. So in the first question here, they want us to, well, everything is on the diagram here. It seems to me that they want us to find angle BAC. BAC. Oh, so that's this guy here. Now, which rule is this? Now, I have a summary of all the rules here. We're going to end up using the cosine rule. Why? Because you're allowed to use the cosine rule if you are given 2 sides and the angle in between those 2 sides, or given all 3 sides. And also today we will be finding a missing angle. So we're using this light blue formula here. Right, so it's a good idea. You can take a snapshot of this or write this back down in your notebooks, so you have, you know, the rules available to you. So I'm going to be using this light blue formula. So to find this angle, let's label the sides. Here's common A, here's common B, and here's common C. We're finding capital A. To find capital A, according to the formula, we have to, well, give me a few seconds to write it back here. So it's B squared plus C squared minus, in brackets, A squared divided by 2 by B by C. Let's fill in the values here. Pretty straightforward. We just have to take our time and work out the top piece, write it down, work out the underneath piece, write it down, and then divide. Do not attempt this entire calculation on your calculator. Do it piece by piece. So B is how much? 9. So we have to take 9 squared. C is 11. And A is 15 squared. Divided by 2, multiply by 9 by 11. So let's work out the top here quickly. Oh, I have my calculator. Obviously, I have my calculator. It's on the screen here. 9 squared plus 11 squared minus 15 squared. On top, we get minus 23. Divided by 2 by 9 by 11. So 2 by 9 by 11. And we get 198. Let's divide this. Now, here's a common mistake. Now, it just so happens on top. Look at on top. We have minus 33. Not all the time you will get a minus number, but today we did. So please don't forget the minus sign like it's not important. It's super important. Minus 23 divided by 198. You just can't ignore a minus sign because you feel like it. If it's part of the number, please write it back. So when you divide these two, you're going to get minus 0.116. I'm just going to 3 decimal places. And now we have to cos inverse this. So second function, cos minus 0.116. You notice I did not ignore my minus sign. It's super important. And when I do that, I get 96.66 degrees. And that's the end of the question. This angle here is 96.66 degrees. Look at that. Right? Not too bad. So, save in case we need to go back. Great. Oh, here we have a bearings question. So I really hoped you watched the bearings question and made proper notes. In this question, we're going to try to find how far apart G and E are. G and E. Oh, that's this. That's G and E. That's this here. Right? Don't worry about that letter N there. Right? So that's mistake. So we have G and E. So then let's fill in some information. Now I believe I did another diagram below here, just in case we needed to write plenty information. But let's fill in everything here, and if it looks too complicated, we'll summarize it below here. All right, so give me a few seconds here. This is the first time I'm doing this question. From G, that means we're starting at G. The bearing of A is 52. So that means this angle over here is 52 degrees. Remember, bearings are measured from north in a clockwise direction. From A, that's this sentence now. From A, the bearing of E is 216. So that means this angle here from north spinning in a clockwise direction is 216 degrees. Right, let's see what's going on here. Let me get a different color here. Let's draw a little cross here. Let me zoom in here a little bit. I don't think we can zoom in here. Well, let me save here. Oh yeah, we can zoom in. All right, so let's draw in. Let's draw the cross here, right? I think we have a straight line tool here. All right, so we have east, south, and west. Okay, my advice is we have to try to find. I would really suggest if we try to find this angle over here. We really want to try to find this angle. Once we have this angle, we will have two sides. Notice the length of two sides and the angle in between. So let's see if we can reason out that angle. Well, I believe that we can find this angle here very easily, this blue angle here, because from north all the way to south is 180 degrees. But you notice this red line does not stop at 180. It continues until they acquire 216. So we can find this angle here very, very easily. You just have to take 216 and minus 180. And you will get 36 degrees. Right? Because 36 plus the 180 from south to north will give you back the 216. All right, now check this out. This one that might not be obvious. You all see a Z angle here? I'm going to trace it from north to G, go up the slanted line to A, and go back down to south. I need a different color so you all can see this. Where can I find a different color? I can use probably orange. This entire angle over here, right? From here all the way here is 52. So from here all the way to here is 52. That's a better way of drawing it. So in other words, if we add the green angle and the blue angle, we're supposed to get 52. So we can more than reason out the green angle. Take 52 and minus the 36. So that's what I'm going to do. Take the 52 and minus the 36. And we will get 16 degrees. So this angle here is 16 degrees. So now knowing here 16, let's go down and see what happens to this diagram. I think this could be a little bit easier here now. We know here is 16 degrees. We just reasoned that out, and we have the two sides and the angle in between, and we want to find GE. So let's put in our common letters. Common A, common E, and common G. Which rule is this? Well, to me, it seems to be the cosine rule again, but this time we're trying to find a missing side. You notice we are allowed to use the cosine rule because we have the length of two sides and the angle in between those two particular sides. So we're trying to find angle E. So to find angle A squared is equal to E squared plus G squared minus open brackets 2 by E by G multiplied by cosine capital E. Let's plug in the values here. A squared, how much is E? 200. So that's 200 squared plus G is 160 squared. Sorry, that's squared. Minus 2 by 200 by 160 multiplied by cosine A. Capital A is 16 degrees. All we have to do is type in this on our calculator. That will give us A squared. And then we will just need to square root the final answer. Because when you throw across a squared, you get a square root. Now let's type in this straight on our calculator. 200 squared plus 160 squared minus open brackets 2 by 200 by 160 multiplied by cosine 16 close brackets. Voila! We get 4079.25, and we just need to square root that. So we square root that answer, and we get roughly 63.87 kilometers, and that's the distance from G to E. And just making sure the recording button is still on. Oh, thank God. All right. Moving on to the next question. Let's see what happens here. Let me save it. It's a new program I'm using, so it's kind of tricky. Okay, so part E. Find the length of BD. This here is a right angle triangle. You can watch it on the diagram here. All right, hopefully this doesn't give us too much problems. So everything they're saying in this paragraph is on the diagram already. They said they bisect the line. They said the line BD bisects the angle ABC. Now, just if this is a 90 degrees and they are saying BD bisects this angle, this has to be 45 degrees, right? Because it bisects the angle, right? So in case you don't know what bisect means, right? Bisect just means the what? Cut in half. So if you have 90 and you divide it by 2, you will get 45 degrees. So I'm going to put that down one time just in case. What are they asking us to find in this question? Oh, it's on top here. I got confused there. So they want us to find BD. All right, so they want us to find the line BD. Let's see how we can go about this. Like I said, this is the first time I'm actually doing this question. To find BD, let me think on this for a few seconds here. All right, so I think I figured it out. I think we need to find this angle first here. Pay attention to the big triangle. That's a right angle triangle. I think we have to use tan. Tan theta is opposite over adjacent. So we want to find this angle here, x. So that means tan x is equal to the opposite side. If you're standing here, the 18 is opposite and the adjacent is 6. So it's 18 divided by 6, which is 3. We have to tan inverse that. So x is equal to tan inverse of 3. Let's see what we get, right? So 1 second. Double checking something. All right. Second function, tan 3. And we get roughly 71.57 degrees. So let me save it here. Zoom in. This angle here is 71.57 degrees. Remember, they want us to find the length of BD. I think well, let's find this angle here one time, right? I think it's going to be very, very useful, because even if it's not useful, once you have two angles in a triangle, I always suggest find the third angle. All the angles in a triangle add up to 180. So I'm going to add these two and minus it from 180. So it will be 180 minus, open brackets, 45 plus 71.57 close brackets. So this angle over here is going to be 63.43. If here is capital C, let me get a different color. Yeah. If here is capital C, over here is common C, capital B, common B, capital D, common D. We are trying to find common C. So it seems to me that we have two angles on one side. That's a case of the cosine rule. That's, no, I don't have the, oh, look at it. That's the cosine rule for the non-right angle triangles, right? You can use this if you're given the length of two sides and one angle opposite to one of the sides, or given any two angles on one side. So I have two angles and I have at least two angles on one side. So let's write the formula here for this. Where would I have more space? Over here, I think. I want to find common C, so it's C divided by sine capital C, and I'm going to keep the D's. D divided by sine capital D. So I'm going to just exclude the B's. I'm not going to deal with the B's, because I have enough information between C and D to figure out common C. So C divided by sine capital C is 71.57 divided by common, so it's equal to common D, which is 6 centimeters, divided by sine capital D. Let's work out this on our calculator. Let's work out this on our calculator, then cross multiply. That'll be easier. So let's see. Sine 71.57 is 0.95, and the other one is sine 63.43, and that's 0.89. Let's cross multiply. C multiplied by 0.89 is equal to 6 multiplied by 0.95. I guess I can do that straight on the calculator. 6 multiplied by 0.95 is 5.7. We want to solve for C. C is a multiply. Throw it across, you get a divide. So 0.57 divided by 0.87 gives us 6.55, right? Oh, I made a sign mistake here, so it's 0.89. Let's do that back. 5.7 divided by 0.89 is 6.40, right? And it will be in centimeters. So we just figured out the question. The length from B to D, which is common C, is 6.4 centimeters. All right, so let me save that. Ooh. Scroll down. Oh, yeah, that's the end. That's the end. All right, so I really hope that you enjoyed part 9 of the series. I have one more video to do, and of course, guys, if you're interested in extra lessons and you're from Trinidad and Tobago, this here is my flyer. You can find my number in the description below. So guys, thank you for watching, and of course, don't forget to like, subscribe, and share, and of course, comment. Take care, guys.